Here we see a sloped surface on which a wheel is placed. A rope is then attached to the top of the wheel and a force is applied to keep the wheel in static equilibrium. Given the state of static equilibrium, we need to determine the tension in the rope. The known variables are the mass m and radius r of the wheel, the angle of the slope alpha, and the gravitational acceleration g. To break down the mechanics, we first mark all the required forces in the diagram. The weight force is denoted by mg and acts downwards from the center of mass of the pulley. The tension T acts along the rope and friction F acts along the surface at the contact point between surface and the wheel. Furthermore, the wheel's radius is denoted by r and the angle of the slope is alpha. In the case of static equilibrium, we know that the sum of forces is equal to 0. To simplify our task, we resolve the forces in the direction of the slope. Then we get T plus F minus mg sine alpha is equal to 0, where mg sine alpha is the weight force mg resolved in the direction of the slope. Since it's acting down the slope, it will be minus. The sum of moments is also equal to 0 since the wheel does not rotate in static equilibrium. We take moments in the clockwise direction around the center of mass of the wheel. We then get a moment of Tr from the tension in the clockwise direction and minus Fr from the frictional force. The force mg and also the normal force N acting from the surface onto the wheel does not contribute to the rotation since these forces pass through the center of rotation. Additionally, force N do not contribute to the first equation as well since it is perpendicular to the slope. Therefore, we can ignore it altogether. To solve for the tension value T, we multiply both sides of the first equation by R and then add it to equation 2. When we add the left hand side of both equations, plus Fr and minus Fr cancels, giving us 2Tr minus mg sine alpha r, and the addition of the right hand side of both equations give us 0. We then solve this to obtain T equals mg sine alpha over 2. In this example, we saw that through careful application of basic mechanics laws, such static equilibrium problems can be easily solved.